Hi everyone, welcome back to my channel. In today's video, we are going to discuss Kirchhoff's laws. We'll cover both Kirchhoff's current law and Kirchhoff's voltage law, and I'll walk you through some example problems to show you exactly how to apply these laws in different circuits. Let's get started. We have studied and applied Ohm's law for simple circuits, but just Ohm's law is not sufficient to analyze the circuits. So, when Ohm's law combines with Kirchhoff's law, it becomes a powerful circuit analyzing tool. Kirchhoff was a German physicist who stated two laws. The first law is known as KCL or Kirchhoff current law, while the other is Kirchhoff voltage law or KVL. Kirchhoff's laws, along with Ohm's law, form the basis of circuit theory. Kirchhoff current law states that, in any electrical network, the total current leaving a junction is equal to the current entering the junction. Alternatively, we can say that the incoming current is equal to the outgoing current. For example, we have a network in which 5 currents are flowing. I1 and I2 are incoming currents, while I3, I4, and I5 are outgoing currents. According to KCL, we can write that I1 plus I2 is equal to I3 plus I4 plus I5. An important point to consider here is no charge will be accumulated at node. Therefore, KCL law is based on law of conservation of charges. The second Kirchhoff law is KVL or Kirchhoff voltage law, which states the algebraic sum of all the voltages around the loop is 0. Alternatively, we can write sum of voltage drops is equal to sum of voltage rises. Let's suppose we have a simple circuit with polarity of voltage drops. What we will do? We will start from a node, passes from all the nodes, and return to the starting node. It is important to note that the term algebraic sum means the sum in which we takes the polarities as well.
Let's write KVL equations for this circuit. We start with source in clockwise direction. But it is not essential. You can start from any point and in any direction, passing through all the nodes and writing voltages along with polarity, which is very important. So it will be minus VB plus V1 plus V2 is equal to 0. And V1 plus V2, which are voltage drops, will be equal to VB, that is source voltage. Hence, the voltage rises or EMF will be equal to voltage drops in the circuit.